All right, this is section 8.3, day 2, and we start out with the dot product of vectors in a plane. So we have the dot product of A is A1, A2, and then B is B1, B2 is defined as the dot product is multiply the X values and multiply the Y values, and it's always addition in the middle. And we talked about yesterday how if the dot product is 0, then the vectors are perpendicular to each other, and we say that those vectors are orthogonal. Find the dot product to determine orthogonal vectors. Find the dot product of u and v, then determine if u and v are orthogonal. So u dot v is equal to multiply the x's, negative 15, always add, and multiply the y's, and that'll be negative 2. So the answer is negative 17, and then we have no. Those are not orthogonal. The dot product is not 0. So u dot v here is negative 2 and 9 is negative 18. And then add positive 18, and then the dot product is 0, and then we say yes, orthogonal. And I think the answer in the back of the book or the solution manual will say orthogonal or not orthogonal. Use the dot product to find the magnitude of the given vector. The magnitude squared is equal to b dot b, which would be 144 plus, because we're squaring 12. And then I don't have 16. Is it 256 times 16? Hey, look at that, 256. 256. And then 144 plus 256 is 400. 400. And then if you, that's the magnitude squared. So if you square root both sides, the magnitude of b is 20. And there's 20 right there. Let's do one more. Magnitude of c squared is 1 plus 49, because we're doing the dot product. So we multiply the x's, multiply the y's. So the magnitude squared is 50. So the magnitude of c is equal to, well, the square root of 50, which is 5 square root of 2, because 50 is 2 times 25. Angle between two vectors, have this formula memorized. Cosine of theta is the dot product of A and B divided by the magnitude of A, magnitude of B. So I've left the answer here. Let's see if we can get this answer. We got the cosine of the angle is equal to the dot product between these two, which is negative 20 plus negative 8 over the square root of, Pythagorean theorem here, 25 plus 4. And square root of 16 plus 16. That's going to be negative 28 over square root of 29, square root of 32. So negative 28 divided by square root of 29 divided by square root of 32. Now that number is between negative 1 and 1, so we're good to go in that aspect. Negative 0.9191, keep on going. And we need to take the inverse cosine of that answer. And there's the 156.8. So theta equals 156.8 degrees. Let's try one more of these. Cosine of theta is equal to the dot product. So negative 54 and then plus 35 over the square root of 81 plus 25. That's the magnitude of u. And then square root of 36 plus 49. So let's have the calculator do the work here. Negative 54 plus 35. We'll get that divided by the square root of 81 plus 25 divided by square root of 36 plus 49. All right, we got a number between negative 1 and 1. That's always good. Negative 0.200166. Keep on going. Now we're going to take the inverse cosine of that answer, and we get the 101.5. So theta is 101.5. A plane has a bearing of 35 degrees with a speed of 48 knots. So bearing of 35 degrees, 035. So here, let's call that 035. It should be nice and straight. And that's 480. Well, if this right here is 35 degrees, then this right here is going to be 55 degrees because those two need to add up to 90. So there's the unit circle measurement for that vector. There is a wind blowing from, you got to be very careful, from a bearing of 290. So there is 90, 180, 270, and another 20. Another 20 is 290. So the wind is blowing like that. Well, if this is 20 degrees, that'd be 270 to 290. That's a 20-degree gap there, 20-degree angle. So by vertical angles, this should be 20 degrees. So now the unit circle measurement going all the way around like that is 20 degrees short of 360. So we're looking at 340. All right, now we need the resulting vector. Ooh, okay. Have to bend that a little bit. There we go. This magnitude of the wind, by the way, is 65 knots. So we need the 480, the 65, the 340, and the 55. So the plane, 480 cosine of 55, 480 sine of 55. The wind, all right, the wind is 65 cosine of 340 and 65 sine of 340. And let's get the resulting vector for this. Here we get the calculator. 480 cosine of 55 plus 65 cosine of 340. And we're going to store that into A. Let me see if I can fit all this on the screen. Just do it all in one shot here. 480 sine of 55 plus 65 sine of 340. And we'll store that into B. Stay on the screen. There I can see them. 336 and the 370. So the resulting vector is 336.39 and 370.961. 370. So now if I've stored this into A and this into B, the magnitude of R is the square root of A squared plus B squared. So let's do square root of A squared plus B squared. And we get 500. So 500.7 knots. And then the angle is the inverse tangent of B over A. And of course, we're going to get a unit circle measurement for this. Inverse tangent of B divided by A. And that's 47.797. Keep on going. But that is this angle right there. Now we found the X component. That's the 336. And we found the Y component, which was the 370. So we found this unit circle angle right here, which was 47, but the problem is given as a true bearing. So we want this angle right here. We want from north. So these two, this one and this one, should add to 90 degrees. So we're going to take 90. Whoops. Ooh, that was weird. 90, and we're going to minus the answer. So we're looking at 0.42 degrees. And I thought we could review. State whether each quantity described is a vector quantity or a scalar. A box being pushed with a force of 125. That's a scalar. Because it doesn't say direction. Wind blowing at 20 knots. That's a scalar. No direction there. A deer running 15 meters per second due west. There's a vector. A baseball thrown with a speed of 85 miles per hour. That's scalar. There's no direction. A 15-pound tire hanging from a rope. That's a vector because we know the direction is down. We're not going to do all of these. Draw a diagram that shows the resolution of each vector into its rectangular components. Then find the magnitudes of the verticals, horizontal and vertical components. We might skip a little bit of that. This is number 38, and 310 degrees to the horizontal, so we got to go 310 degrees. There's 270. Another 30 is 300. I don't know, 310, about right there. About right there. And then to find the components, it's 2 1/8 inch cosine of 310 and 2 1/8 sine of 310 if you want to find the component form of that. How about let's do number 39. It's got a different measurement here. And this says, the way I read it is 49 degrees east of north, on the east side of north. So 49 degrees, here would be 45, let's say halfway. So 49 would be, let's say here. And this would be the 49 degrees on the east side of north. And then the last one we should probably talk a little bit about is number 41, the third different one, is 255 degrees. It's 255 degrees. So we start at north if it's a true bearing, and we go to, this would be 90, 180, all the way to here would be 270. So 255, I would imagine, is somewhere right there. So this is true bearing. This one was from the horizontal on number 38, and this is that the quadrant measurements. Find the component form and magnitude of AB with the given initial and terminal points. Find the component form. So like number 1 is 4 minus -3 and 5 minus 1. So that's 7, 4. So we subtract x2 minus x1, y2 minus y1. And there's your component form. Find each of the following for F, G, and H. How about we do, and let's just not go too crazy. Let's do number 12. Number 12 is 8, 0, and then plus 2 times H, -6, 2. And this is just order of operations. So we're going to multiply first, -12, 4, and then -4, 4. So when we add the x's and we add the y's. Find a unit vector u with the same direction as v. So here we have, let's just grab number 20 here. We need the magnitude of v. We divide each of these by the magnitude of v. So square root of 4 plus 49 is square root of 53. So the unit vector is -2 over square root of 53 and 7 over square root of 53. Now, if on the test it's a multiple choice and they've rationalized the denominator, then that's going to be -2 square root of 53 over 53, because we're going to multiply the top and bottom by the square root of 53, and we're going to do the same thing over here. So 7 square root of 53 over 53. So there it is, rationalized. Let DE be the vector with the given initial and terminal points. Write DE is a linear combination of vectors I and j. Let's grab number 28, and that's going to be 5 minus 4 and -7 minus -1. So 1 and -6. So that's going to be 1i plus, or actually, we should probably do 1i minus 6j. You could probably do plus -6j, but if it's a multiple choice question, that's probably how it's going to be written right there. Find the component form of v with the given magnitude and direction angle. So component form is going to be 12 cosine of 60 and 12 sine of 60, just like we've been doing with the airplane and the wind problems. You know, we've been doing this quite a bit now. But we know cosine of 60. So again, I'm thinking multiple choice. They're going to have you write, they're going to have the actual, the exact, I can get this, the exact answer of the problem. So cosine of 60 is square root of 3 over 2, and sine of 60 is 1/2. So now we have 6 square root of 3 and 6. If it's an angle that we don't know, and I think we know all of these, so if it was magnitude of v equals 7 and theta is equal to 105 degrees, then we're just going to use a calculator and get a decimal answer. Find the direction angle of each vector to the nearest tenth of a degree. And let's get one that is not in a principal quadrant, which would be, like number 45. So that's -2 and 1, 2, 3, 4, 5. -2, 5. All right, there. So we want that angle, but of course we're going to use the reference angle. So we want inverse tangent of 5 over -2. So let's do inverse tangent of 5 divided by -2. So -68, -68.198. So it's actually saying that the angle is down here, which it's not. We know it's in quadrant 2 rather than in quadrant 4. We have to add 180 degrees to this. And so the answer we're looking for is 111 to the nearest tenth, 0.8 degrees. Find the dot product of u and v. So now we're kind of getting into 8-3 territory. So u dot v is equal to, and we multiply the x's, 18. And we add, always add, multiply the y's, -10. And we get 8, and so that is not orthogonal. No. Not 0. Use the dot product to find the magnitude of the given vector. So the magnitude of m squared is equal to m dot m. And we end up doing, part of the Pythagorean theorem because we're squaring x and we're squaring y. So 9 plus 121, that's going to be 130. Now that's the magnitude squared. So the magnitude is the square root of 130. Find the angle theta between u and v to the nearest tenth of a degree. How about we grab, and how about number 19? Number 19, because then I don't want this to be confusing to you. That is exactly the same as u being -2, 3, and v being -4, -2. All right, so we need the dot product. What are we doing? Angle. So cosine of theta is equal to, multiply the x's, 8, multiply the y's, -6. Then I need the magnitude of u, which is square root of 4 plus 9, and the magnitude of v, which is 16 plus 4. Let's let the I know I can do some of this. 2 divided by square root of what? 13. Square root of 13, and then we divide by square root of 20. Need something between -1 and 1. Got it. Cosine of theta is equal to 0.124. Keep on going with that. Inverse cosine of the answer. So we're looking at 82.9 rounded degrees to the nearest tenth. And that's it. There's a review of 8.3 and a review of the whole chapter. So this video got a little long. Hopefully that was informative for you, and have a good day.